me just turn on the live stream. That should be streaming now. Let me just pull the chat up. Weird. Well, I guess I'm just gonna start. I can't see the Twitch chat for now. That may be because of time boxing and how Twitch streaming does it. Let's double check those settings. This. Okay, that's fine. I guess I'm just gonna start. So, hi. I apologize if anyone was waiting around. There was a little bit of a mix-up with some of the time slots on Twitch versus the Calendly booking that we made for this stream. So, I'm here now. It's all good. We're gonna be doing the Freelancer Rates exercise in Gleam today. So, a little bit of an overview of how some of the mathematical operators work in the Gleam language. I think they're kind of fun and unique in terms of their syntax. So we're going to go through that. Yeah. So I've got the exercise open in the editor just so that maybe anyone new. I know this is geared towards new functional programmers, so maybe anyone new to Gleam itself can follow along with the track in Exercism. Currently, Gleam doesn't have a learning track, but it does have the practice track. So it's got all those exercises there that you can walk through and kind of use to bolster your knowledge a little bit. So, yeah, let's read through the instructions and sort of get a high level overview of what this exercise is about. And then we're going to step through each of the steps in order and complete the functions in order. So in this exercise, you'll be writing code to help a freelancer communicate with a project manager by providing a few utilities to quickly calculate daily and monthly rates, optionally with a given discount. We first establish a few rules between the freelancer and the project manager. The daily rate is 8 times the hourly rate, so 8 hours in a day, that makes sense. A month has 22 billable days. A freelancer is offering to apply a discount if the project manager chooses to let the freelancer bill per month, which can come in handy if there's a certain budget the project manager has to work with. Discounts are modeled as fractional numbers representing percentage. So, for example, 25.0 will represent 25% discount. Okay, that seems fairly straightforward. We can see our template here, the scaffold for the exercise has 4 functions written out for us. So we've got a function called daily rate, which takes an hourly rate as an integer and is expected to return a float. We've got a applied discount function. So we've got the before discount price as an integer and the discount as a float, and this is expected to return a float. We have a function called monthly rate, which takes an hourly rate as an integer and a discount as a float and is expected to return an integer. And then we also have a days in budget function. So this one takes 3 arguments. It's got a budget as an integer, it's got an hourly rate as an integer, and then it's got a discount as a float, and it's expected to return a float. So yeah, let's have a look at the first step here. So our first step or our first function is to calculate the daily rate given an hourly rate. So we have to implement a function that calculates the daily rate given an hourly rate, which is passed in as an integer here, we can see. So for those who are new to Gleam, it's a strongly typed language. You can see here we've got typing in our parameters here. And this sort of feeds into why, which I'll show you in a minute, but so we have different mathematical operators in Gleam based on whether you're looking to operate on integers or floats. So we're going to have to do a little bit of parsing here because our integer type parameter doesn't match the return type of a float. So we're expecting a float to come out of this function. So the example they've given here is that if they call the daily rate function with 60 as the parameter, we're expecting to get a daily rate of $480 because that's 8 times 60. 8 hours in a day makes sense. So the way I would do this is, we'll get rid of this to do here. So like I said, Gleam has specific mathematical operators for both integers and for floats. I've got the documentation, well, not the documentation, but Gleam has a very handy language tour that you can find on the gleam.run website. It's a really, really great way to sort of get your head around some of the concepts in the language. So you can see here in the int and float section in the Gleam language guide, integers are whole numbers. So we can see a couple of examples of sort of mathematical operators here. They look pretty standard if you've done anything in other languages before, like 1 + 1 = 2. You know, they're fairly standard. We've got greater than, less than. We probably won't be using those in this exercise, but they're good to know about. When you're dealing with large numbers, it's really nice to sort of have this underscore separator just for visual clarity. If you've got a ton of information on your screen, it can help with parsing it quickly. But what we're sort of interested in here, because our function is expected to return a float, is floats have their own operators. So you can see here that they're the same as the integer operators, but they're denoted by a full stop next to them. Now, this is really nice. If you've ever done anything in, say, JavaScript, for example, you'll know that math can get a little bit weird. So having both the strongly typed language Gleam and these sort of specific operators for floats and integers, like they're denoted separately, that makes very, very fault-tolerant programs when you're dealing with anything mathematical. So we're going to be wanting to use something like this for ours because our exercise here is expected to return a float. Now, our parameter here, hourly rate, they're giving it to us as an integer, which is fine. Nice round number for an hourly rate. But we're going to need to do some parsing because you can't, due to the fact that floats have their own operator and integers have their own operator, you can't have a mathematical operation in Gleam where you have an integer operating on a float. So because we want to return a float, let's also convert our integer to a float, our hourly rate parameter to a float. So in Gleam, you can do this by calling int. Well, you will need to import the library for this. So to do that, we grab Gleam/int as an import. And then we can call int here, and there's a method on int called toFloat, which will just parse it to a float for you. And we're going to put in our hourly rate parameter. So this will turn our hourly rate integer into a float. And then we're going to call the float multiplication operator. So that looks like this, a little splat and a full stop, to denote that it's operating on a float. And we're going to times that by 8.0, to get our result. So if we run the tests now, we should see here. Well, that's annoying. So we've got 4 tests and we've got 3 failures. Our first test is now passing, which is good. It's a little bit annoying that I can't see the passing test in here, but that's okay. So you can see here, there's like a test for daily rate. for those of you who aren't sort of super across the Exercism platform, this is where everything lives. So you've got your tests and the test results once you've run your current code here. So you can see that there's a function, a test rather, for the daily rate function, and it's expected that passing in 60 here will return 480.0 as a float, and that will give us our daily rate. So this one's passing now, which is great. So if we go back over to our instructions here, let me just double check over here. Yep, that's storing. Okay, cool. We have to calculate a discounted price. So we have to implement a function to calculate the price after a discount has been applied. And we're passed two parameters here, the price before the discount, which is an integer, and the discount, which is passed in as a float. If you remember before, discounts are modeled as fractional numbers representing a percentage. For example, 25.0 would be 25% discount. So in this example here, we've got a rate of $150, presumably, before discount, and a 10% discount. So that's expected to return $135. So let's do it. Get rid of this. So I guess for a little bit of code clarity, let's parse this before discount integer. So we're expected to return a float here again. So we're going to have to do something similar to what we did up the top here, where we have we're parsing this integer so that we can operate on a float and return a float. So let's do that again, but I'm going to set this to a variable just for a little bit of code clarity. So we're going to let's call it initial price equal, we'll call that int library again to float on our before discount. And that will give us our initial price as a float. So it's like a dollar amount. And then what we can do is we can then apply a discount like you would in sort of any real life situation. So what we're going to do is take away the initial price. How would we do this? So we want to apply a discount to the initial price based on the discount parameter here. So I think what we want to do is take the initial price, and we're going to take away, and remember we're returning a float, so we have to use the float operators here. We want to take away the initial price multiplied by, again, we've got the float operator, the discount divided by 100. Now, to pass an expression in Gleam, use curly braces, so that's what we're going to do here. Yes, we're going to multiply that by the discount divided by that float operator, 100.0. That has to be a float because we've got a float on either side of that that operator. And I think this should make our second test pass. So we should see 2 passing tests now, and that's what we see, which is great. So let's look at the tests. So this is the test that we had for this specific function. We've got Freelancer Rates when we call the apply discount function with 150 as the initial price and 10% as, just scroll across there, 10% as the discount rate. It equals $135, and this is passing, so we know that this is working correctly, which is great. So yep, return value should always be a float, not rounded. Perfect. Let's move on to our third function. So we want to calculate the monthly rate given an hourly rate and a discount. So we can see here that hourly rate is passed to us as an integer. The discount is passed as a float, which is what we're expecting. And this is expected to return an integer. So, okay. And the example here, so implement a function to calculate the monthly rate and apply a discount. So we have an hourly rate of $77 here. They're applying a 10.5% discount, and they're expecting this to come out to $12,130. Okay, great. So, and it also has a note here. The returned monthly rate should be rounded up, so we want to take the ceiling, to the nearest integer, because, yeah, we're applying a float discount here. So we want to round this to a nice whole number. So, okay, yeah. Now, if you remember, up here it was described that a month has 22 billable days. So this is going to be sort of our multiplier for finding the monthly rate, which is all good. So let's do it. Get rid of this scaffolding here. So, okay, so we sort of want to do the opposite here because we're returning an integer. So we want to be parsing our float here, our discount parameter, into an integer to make sure that our operators work correctly. We'll be using the integer-based operator syntax here instead of the float-based operator syntax. So let's think. Let's first calculate the price for the month using the hourly rate that we get here before the discount is applied. And then we can apply the discount to that value using the function that we just wrote up here with the apply discount function. So let's call it, I guess, like before discount. If I could spell correctly. So we're actually going to need to import something else up here, which is the float library, because we're doing the opposite here. So float has a method called round, which is really handy. And we can do that to parse this float value that we've been passed for discount into an integer so that we can operate on it using the hourly rate. So let's call the float library and let's call the round function. So we want to get the daily rate first, which we can do because we've got a function for that, and then times that by 22 for 22 days in a month. So let's call our daily rate function and pass in the hourly rate like we normally would using that function. And then we want to multiply that. Now that's going to be a float, that'll return a float. So we want to use the float operator here and then times it by 22.0. And that should give us our monthly rate before any discount is applied. And then we can use that variable to apply a discount using the function that we wrote previously. And it should return the monthly estimate with the discount applied. So what we can do now is we call our apply discount function. And then we want to put in the before discount value, which we just created. So this is going to be the monthly value before the discount. And then our second argument should be the discount itself. So we've got that as a parameter. And then we can put that in as our second argument. And then the other thing that they specified at the end here is we need to take the ceiling. So we need to round up to the nearest integer. Now, let's have a look here. Let's apply. So we're applying the discount. Yeah, we want to round it up now. So let's give this a variable name just for some clarity. And then float has an additional function, which is called ceiling, which basically does what it says on the tin, takes the ceiling, rounds it up to the nearest integer. I believe. Now, let's call that... No, so float.ceiling... I'm wrong, I lied. Float.ceiling will return the float rounded up. But fortunately, there's another very handy function in the float library called truncate, which will chop off that end decimal. So first, let's round this up to the ceiling. So we want to put in the after discount value to round that up. And then I believe what we actually want to do here is wrap this in a float.truncate. So we've got, float.ceiling after discount, and then we're truncating that rounded up value. So let me just double check that everything looks okay here. We're applying the discount. The before discount value is this times by the 22 days. Yep. Yeah, okay, cool. So let's run this. We should hopefully see 3 passing tests, which we do. Fantastic. So let's just look at that test. So it's the same as the example that we saw in the instructions, but we're basically testing that when we call monthly rate with a value of 77 as our hourly rate, and our discount at 10.5%, it should return 12,130. You can see they're using that very nice separation there, which, again, when you've got really big numbers, it's very handy to have that just for parsing things really quickly in your mind. So that's parsing. That looks really good. Yeah, let's move on to the final function here. So we need to calculate the number of workdays given a budget, hourly rate, and a discount. So we can see over here, the budget itself is an integer. Hourly rate is also an integer. And our discount, as expected, is a float. And the function itself is expected to return a float. So we need to implement a function that takes a budget, hourly rate, and discount and calculates how many days of work it covers. Okay, cool. So this returning a float, maybe there's like a half day of work involved. So the returned number of days should be rounded down. Oh, my bad. So we are rounding the number of days worked. So it should take the floor this time to 1 decimal place. Cool. Okay. So I know for a fact, like float, the library itself, again, has a very handy .floor function, so that should be no problem. Let's get stuck into this. Just losing my voice a little bit. So, all right. First of all, we want to... We're returning a float here, so we need to parse our integer parameters to floats. So we're going to use that very handy int.toFloat again. And we're going to apply that to our budget, which is an integer passed to us. So in this example, 20,000 makes sense. And then, so let's call this total budget. And we also want to get the let me think. So we want to get the discount applied to the daily rate. Yeah, I think that's what we want to do. So let's say discounted rate. Oh, we need to actually declare these with let. That's my bad. Discount rate. So we want to apply discount. We want to use that function that we wrote previously. We want to apply the discount to the daily rate using the hourly rate, because that's what I passed here. But we want to round that. Yes, we want to round that. Okay. So let's do that. Let's go float.round. And then we're going to call our daily rate just to get the day rate using the hourly rate that we've got here, because it's easier to calculate the months using that. So daily rate, and we pass the daily rate function the hourly rate, because that's what it takes as a parameter. And that is an integer, so that should match the parameters for that function just fine. What are we doing? And then the second argument for apply discount is the discount itself. So we have that as a parameter. And it's already as a float, which is fantastic because that's what that function takes, as you can see up here. And then I think, oh, my bad, force of habit from using VS Code. I think what we want to do is use that handy float.floor function, which will take the floor, which we're doing here, to one decimal place. Now, I think the default for float.floor is 1, which, is pretty typical. What we want to do here is return the rounded down number of the total budget divided by, and again, we're using that float operator because we want to return a float for this function, divided by our discounted rate. Yeah, that sounds right. This is why I became a programmer and not an accountant. So yeah, we want to return float.floor. And I think that should. Yeah. Okay, so that passed. Yeah, so as you can see, that's returning a float because we're using that float operator again. So yeah, just to sort of reiterate, these syntactically unique operators for both integers and floats, I've personally find that they just make working with these operations so much clearer and more fault tolerant than working in a language like JavaScript, for example, where math can do all sorts of weird things. I'm sure we all know about, floating point math. If you don't, I highly recommend looking it up if you're new to programming. It's one of the most common gotchas that I've seen personally. But yeah, it's sort of a nice little unique part of Gleam that I personally really like. So let's just quickly look at the test that was written for that. So we're expecting that days in budget, when we're given a budget of 20,000 and a hourly rate of $80, and if we scroll across, an 11% discount, that's expected to equal 35. So yeah, yep, that's the example they use there as well. So 35. So we're expecting that this would cover 35 days of work, basically. Yeah, so that's sort of it. Thanks for watching. I really appreciate it. And thank you to Exercism and the team at Exercism for reaching out to me to stream. I really appreciate it. It's been really cool seeing everyone sort of get on board with functional languages during the month. And yeah, cheers. I'll catch you all on the flip side.